Good morning. Happy Thanksgiving. We're going to do something fun today. Now, I was planning on doing this all day, and then my family informed me that apparently we are doing Thanksgiving at 2 p.m. today. So, it's going to be a little shorter than expected, but we still have, a good over a couple of hours to try this out, and hopefully this gives us a decent indicator. So, the plan for today we're going to try out Tinygrad. And then we are going to see how this does. Now, I do like, I got two of the tiny boxes behind me. And there's some stuff about this project I already know I like, and there's some stuff I'm not so sure about yet. I'm going to be as critical as normal. And really the goal here is to figure out, one, if I like it, and two, if it actually can solve any of the problems we have. Okay. We can do source. Welcome, Pepe. Uh, does this not work with UV? Does this thing not have a setup? I mean, I only have UV on this. Oops. Hey, Jess. Okay, how are you supposed to install this thing? Is this not UV compatible? It's gonna screw up my virtual env, isn't it? UV add, just this. Oh, you need the get prefix, hang on. If you make a new VN, but I have an existing VN. I'm in a VN. The puffer is the... This is the VN symbol right here is the puffer. Is that... What does this say? Requirement matches name Tinygrad, but self-dependencies. Oops. Nope. Let me see if this is... Nothing on Google. Tinygrad UV. I mean, this thing is just gonna make some bullshit up, I'm sure. Okay, apparently I'd messed it up. What did I mess up then? Did I literally just do that? Oh, UV pip install, not UV add. Okay, UV pip install the URL. Fine. My mistake. I haven't had to use UV from direct URLs before. Okay. Check the initial example. And actually, I'm going to just swap these two windows. Happy Thanksgiving. Happy Thanksgiving as well to you. Okay, cool. This installs. So what we're going to want to do here is to make... Let's start with a very simple test. All right? Yeah, let's start with a very simple test. Requires grad true. I think the thing that we are going to want is... We have this mingrew somewhere, no? Or rather, I can just import it. That'll be easier. So this is the architecture that I wanted to test. I think we have enough time to do this full thing. Exploration exploit trade-off. Just the advice that most of the lit in that space is very low quality, Jess. Should I keep my coef high even if my elo delta will be lower? You should just sweep it and stop thinking about it. Yeah, so let's go take this. Default encoder, default decoder, default. Let's see what ops they have built in. We know they have map moles. We can probably just get some basic min grew thing, right? I think that's going to be the thing we ultimately want anyways. But would it be better to get us an initial test first? Probably we do want a better initial test first. So let's just do that. Model. And I know I don't need excuse me. I know I don't need to wrap this, but we're gonna do other stuff with this in a bit anyways. Debug equals 2 to see internals. Cool. What I want to do basically, let me explain. So the very first thing I want to do is I just want to get a flops throughput with a basic torch model and a basic Tinygrad model with some relatively small nets, and then we'll do some more advanced stuff. Like I want to see if we can test some of the min-grew functions out, and maybe even get kernel gen, depending how much time I have. Okay, so is there an API that looks like this or not really? Yes, there is. See, I don't necessarily care too much that you have an API like this, but it's very good that they do have this. In fact, this is almost exactly what we want. Oh, I really like that they don't have a base class. I really, really like that they don't have a base class. This is like, good job. I do not like that they go, like, guys, like, come on. Alright. There, that's better. And screw the Python type system. There. That's better. Hidden size. Size, hidden size. Okay. X equals 1, x dot 1. Cool. Flatten dot relu dot relu dot. Perfect. Very simple. And we're gonna do input size equals 19, or what's it, 128. As this is like a reasonable model for RL. Reasonable, very small model. Yeah, so we do tiny model. This. Ah, so they do actually just have a see if we can do like this. That is slightly obnoxious. Having to do this manually. State always going to be the cheapest way to get observations? Surprisingly, no. There are situations where the state is really expensive and the nets that you need to use for encoding are really hard to optimize. But in most cases, state's pretty good. Let's just do, what do we do? A 4096 batch size. Whoops. X. So ob. Input size. We'll just do the supervised thing for now. Tiny opt 0 grad. Chainy type code is not my favorite, but this is the thing I do like about this is I'm pretty sure this is completely optional, right? Like you can just do it the other way. But this is not bad so far. So far, my only nitpick is this thing not having a get params or whatever. But that's super easy to do. So far this is so good. So far so good. Getting D-type float. Okay, so here we have our first Tinygrad error. Let's see how their errors are. Int tensor getting type float. That's fine. Can we do like .int? Okay, so here we get our first kind of jank looking error. Let's see how their traces are. No, we don't. It's not bad. Because we do see the traces right here in sparse categorical cross entropy at least. The bottom of the stack's a little weird, but tiny obs shape. Yeah, that's what I figured, Jess. P-type. What was this saying? Cannot broadcast. Oh, you dummy. Alright, so now let's go find their docs. They got docs somewhere? Documentation. API reference. Tinygrad ops. Okay, so rand perm, rand int, shape low high. Low is 0, 2. Doesn't need this. Okay, so this is... I guess the laziness makes sense because it's frickin' Python. Yeah, okay. Okay, so this now trains. Cool. So, is it 2 times input times hidden? Is that's the flops, right? Hang on. Actually, we can literally just do this. I'll spot check it, obviously. Multiply accumulates is 2 flops, 1 mul plus 1 add. Flops is max times 2. Matmul flops. Board max times 2. And 1 plus batch, hidden, batch, hidden output. And then the factor of 2, yeah, this is what I expect. roughly 2x forward. Right, it's 2x forward, backward, max equals 2 times this, backward flops is 2 times that, which is, yeah, okay. Batch sized 10. Cool. Let's just do this. Flops per sample. Put. Takes input, hidden output, and batch. We are seeing if Tinygrad is good, basically. We're playing around with it, and we're also gonna do some speed tests on small models. Because, you know, most people testing these libraries are testing them on much bigger models. So, you know, Hot said, you know, Tinygrad's quite a bit behind NVIDIA, on NVIDIA hardware for the bigger models, but then he said, you know, actually, this might be good on small models, so I'm testing this. And the other thing is apparently it can output kernel code directly, so we're going to see if that ends up being useful as well. You know, if I can get this thing to output kernels. And we're doing this until probably 1:15-ish today. And then I got to go for Thanksgiving, evidently. I thought I was going to be here all day, but family has early Thanksgiving plans this year. Hey, Kevin. Welcome. This. Yeah, we're doing the overall per first, Daniel. First times. Flops. This is going to be iter's times batch divided by end. End. Start. What type of neural nets do you usually use in Puffer M's? Well, in Puffer 3, it's a small encoder, small decoder with the core being an LSTM. In Puffer 4, we're looking at a Mingru-based architecture. And it's a little harder to perf optimize, even though it should be much more efficient, so we're looking at this. I think this is without the JIT as well. Oops. Objective type float, really? 0.2f. Oh, dummy. Yes. Okay. So, let's see if we find where is the JIT. Timing of time. JIT of x. How do we do this? This has net as a frickin' global, which I hate, but we'll do that for now. Is it even valid? JIT. That tiny JIT. Opinion about the docs. I've only been using this for the last 30 minutes. Arnins are for previous dates? Yes, for memory. At time JIT. At size. Okay. And this is tiny model. JIT. Not great. Okay. Forward pass. Assert x is not none. Why don't you use the PyTorch front end? I'm just trying Tinygrad today. And what is the PyTorch? What is the PyTorch front end? I don't see anything on here. With grad none. Are you supposed to JIT the entire... How do you JIT the backwards? JIT for eval? Well, then what are you supposed to do for training? Did you do any coding competitions? No. I spent a lot of time building stuff. I actually hate, like, tricky puzzles disguised as programming generally. Like, not something I enjoy at all. They have examples, they have a showcase, but these don't look like examples. Is the... Wait, is this JIT not for training? I'm confused. Best execution speed of any framework. JIT is only for the forward pass? Well, it doesn't work at the moment because this apparently, if I run it like this breaks. So they had this for the forward pass, but like this breaks the backward pass. Yeah, so far, yeah. This page is nice, but then okay, they have examples in here. Man, this should be on the docs. There you go. So you want to JIT. Yeah, you want to JIT the entire train. MNIST is on the docs. Didn't see links to all these samples unless I'm blind. They do have examples. Exactly what I want. I don't like how this is all globals. Oh, they actually have Muon in here already. Good job on that to them. Does this need warm up? This might need to warm up. What the heck is wrong? Oh, I have caps on. Good. Okay, there we go. That's way better at least. What autocomplete are you using? Super Maven, which you can no longer get as a new user. Cursor bought it and killed it, and a few of us users bitched enough on Twitter that they say that they're going to continue supporting it for existing users, which is props to them on that, but I wish they would release the model. Okay, let's make sure this is fully warmed up. Okay, so this is 1 teraflop. 4.91 mil SPS. Let's actually just do Do I trust Grok to not mess this up? This torch. Neural net or the sim model. Warm up is because of the JIT. Mostly because of the JIT. You only can compile the model forward pass with Torch normally, right? Yeah, you can only compile the... Actually, let's not have it mess with it. Like, I can... There we go. Just missed the start. What's up, Tim? Okay. So... $256 iterations just to get... This is a very small model. Ooh, that changes a lot, doesn't it? Alright, that does change it a lot. So it's possibly... It could just be caching something stupid, right? I don't know if that's 110. That might be fake, man. That might be fake. Hmm. It can't be fake, right? Because it's, yeah, there's nothing for it to cache. Because it's the weights are changing, so it has to be real. Okay. Oh, you know why? Is there no... If this just keeps going up, though, then it's cheating. Somehow. That seems really friggin' weird to me. I don't know if that's not like a necessarily unreasonable speed. But like, why? The thing is, you're missing the point, right? It shouldn't be that much of a difference. Yeah, but what could it possibly be caching? It has a fresh model, right? It's running the optimizer on the model. Oh wait, this is the wrong model. So it wasn't benefiting from the warm-up. That's a lot closer. Yeah. Okay, now it doesn't need a whole bunch of iterations to warm up. There's some noise to it. There. Derp. Okay, so 5 mil SPS out of Tinygrad. Unless I have the calc wrong. It's weird it's exactly 1. Okay, it's not exactly 1. Cool. Do this. And then we can check torch eager mode. Teh. Faster in friggin' eager mode. Which I've seen this happen fairly often. Two params, 14 billion SPS. I mean, that sounds cool until you realize that you're actually running like a billion is G. So you're running like I don't know, 0.02 or 0.03 teraflops, something like that. Well, with two parameters, like, that's not even speed, dude. It's like, yeah, it's very easy to get, it's very easy to get 14 bill SPS with, like, 0% hardware utilization. This dude. Hovering from dying from your experiences. Alright, this guy is just not too bright, it seems. So what do we do with this? It's 3x slower than Torch Eager. Most control problems you can solve with under. Okay, yeah, because go try that on Neural MMO3. Let's go look a little bit into the rest of the Tinygrad docs. You need to use Beam. Okay, how do I do that? And where in the docs am I supposed to be looking? There's a section, why so slow? Is it? Are you messing with me? Oh. Yeah, but I'm using the jet. Oh, okay. I didn't, for whatever reason, I didn't, because the showcase was under quick start. Okay. Here, let me read this. Simple model. We aren't syncing the GPU, so GPU time may be slower. Ugh. With context, beam equals 2. Okay. So like this. What on earth? Um, yeah, that's no good. Oh, does this have to go outside? I just so happen to remember that one. That's not on them. I was gonna say they need better error messages, but that one's really not on them. Ooh. Okay. Okay, that is actually that beats PyTorch Eager mode. Okay. I mean, obviously I gotta test versus this now. Because they're basically doing max auto tune. Okay, this is actually... Apparently, this is actually faster than Torch. This is not unusual for Torch, by the way. This is not me doing something wrong. It is actually very often that Torch is just somehow faster in Eager mode with small models than it is in compile mode. Torch is kind of stupid. I don't know what the fuck they do. We'll give them the benefit of the doubt. We'll try their defaults as well. Yeah. So you see, literally, Torch is slower with compile on, and I've had everybody tell me, oh, you're doing it wrong, but no, I've run like a dozen different tests on a ton of different versions of Torch in different machines, and Torch compile is just dog shit. That's simply what it is. Hey, mechanics, welcome. This is actually one of the reasons I wanted to move stuff into C++ with Puffer, was because I just didn't want to deal with Torch compile anymore because it's just so bad. It's like actually worthless. So compared to Torch Eager mode, yeah, we're now getting, a small but that's appreciable speed up here. This is not like, oh yay, time to use Tinygrad. This is like, okay, Tinygrad has passed the first test. Now let's go implement a real model with Tinygrad and see whether Tinygrad is good. Versus Torch with a real model. We're gonna do Mingru. I might just do like one layer Mingru. We'll see. I would like it to be pretty close to the model that I use or I intend to use in Puffer 4. And I think we can do it. I've got Thanksgiving to go to in about an hour 10. Let me fill up my coffee and we'll get started. Yep. The only thing that I will say is a little bit obnoxious here is that you need to use their version of max autotune to get the result. Like their normal JIT is disgustingly slow for these models. So that's a little bit disappointing, right? Like you shouldn't have to search kernels to beat the defaults, I wouldn't think. But then, I don't know, I guess you really shouldn't have to. Okay. Welcome everybody. Happy Thanksgiving. Oh yeah, for everybody who's new around here, this is a special stream today, but I kind of stream all of my dev. So if you're interested in high performance reinforcement learning, all open source, check out puffer.ai and feed that puffer a star. Helps me a ton. We got tons of demos here. We got discord.gg/puffer. We got tons of educational materials as well. And this is pretty much just cutting edge research done in public. All right. Now what we're going to do mingru.py. Now we're going to replace this model with mingru, which I already have an implementation of in here, and I just have to modify up a little bit. We're going to modify this, a little bit, at least. Not a GRU, it's a mingru. So if you have not heard of this architecture before, it's pretty cool. So it is a linear time recurrence architecture, which means that it can take hidden state and give you next hidden state, so it can have memory, but you can actually train it in parallel. So you can do all of the matrix multiplications for the entire sequence, even though it has hidden state in parallel, which is pretty cool. So what we're going to do is we're going to just make like a super simple version of this, or like a super compact version of this. And then we're going to get this ported to Tinygrad. This expansion factor is moderately annoying, I believe. No, actually, it's fine. Would you ever show an end-to-end on how to train something with Puffer and see it play? Not sure how to see the behavior. Try breakout instead. Yeah, it's super easy. Profiler and debugger. Not yet, E10. First of all, I don't need the breakdown until I get a basic overall speed. That's gonna be the plan. Pay no attention to this 2 mil SPS. This is like super dev mode stuff on 4.0. It'll be way faster than this. The goal for Puffer 4.0 is 10 million step per second training. And I really don't think I'm going to release it until I hit that, because I know it is possible. It just is going to take some engineering. I already have like a few of the final kernels pretty well done as well. It's just the vectorization and like a couple more kernels, a few other optimizations here and there. Current bottleneck, vectorization's eating like 3-ish mil SPS, and I don't know what I'm going to do about RMS norm because I need that, and that's super slow. There's kernel launch overhead. Okay, so would you mind showing him? I wanted to just show him here really quick, but I forgot that I don't have loading working on Puffer 4 because I'm on the dev branch at the moment, and I don't have it working from Python. If Tinygrad is good for you, will you port everything to it? I'd say that's fairly unlikely, Danielle, unless apparently there is a Torch front end. So if my users can't tell the difference, then maybe. I think the far more likely thing is that we use their kernel gen, but we will see. Yeah, I was gonna show you Hyper, but I'm kind of in the middle of this dev branch. What happened to default? Yeah, and I gotta focus because I only have an hour to do this. Right, so this mingru code is not good or anything, right? This is like mostly ported from random Lucid Rain implementation. So you get default encoder. And I don't think we need this, right? I think I can just steal this encoder off. Yeah, I can totally just steal this encoder off like this. Obs. Default decoder, and all I need is... I need this one. No, not continuous. Here. This one. Okay, this is self-decoder. This is self-value. Now we can get rid of both of these. I'm going to swap the relus to get the gelus to relus, I think. I guess we'll see what operations Tiny has built in. Before I go and do that. We'll get rid of the puffer inits, just for simplicity. All right. There we go. And then this will just be called Tiny Model. No, we actually will just replace this. Okay, so this is gonna be min grew. Grew. And then this is output size. No, input size. Output size, hidden size. Like so. And let's make this run. X shape. Star 2. We just do b et x dim x dot shape. Not enough values. Right, so we have to change this to a sequence model. So I guess actually we can make this way easier because the only thing we're really gonna care about is we mostly care about this eval pass, right? Gotta be some simpler way we can test this stupid thing, right? Or not particularly. I suppose for now the quickest thing is just gonna be to take the obs. We do this. Good. Does this get initial state? It does. Yes. Where's device? Hmm. What happened here? Oh, is the model not on the right device? Try this. Cool. Values. Eight. I think this is good enough. Do the forward pass. Like this. Okay, and this is not remotely the right number of flops. We can just get SPS out of this for now, right? Okay. So here we have our current MinGru implementation, right? We've got our synchronize, benchmark, synchronize. Should be good. See? This missing the RMS norm. How is this missing the RMS norm? Hold on. No, it's not. We have the RMS norm in here. Good. Very good. Now we want to implement this exact same thing in Tinygrad. So this will be the question, is how hard is this, right? Okay. So this torch model. The first thing we want is Einstein associative scan. We can go grab a couple things from Torch. Go grab a few of these things, right? Like this is all the same. Except, and we have to do this. We do have a cumulative sum. Tensor of elements selected from either X or Y, depending on self. Let me see. Return X 0 dot where, like this, right? And this is going to be X relu minus do that. I don't think it's even valid. Hello, Rui. Welcome. No, you can't do that. Let's see, soft plus. How do you import all these methods? Let's see. Surely they have they should have this here. Soft plus. Tinygrad.tensor.soft plus. They not have oh, I see. They probably just made it so you can do tensor.soft plus. They probably just do it like this, right? So you can just do from tinygrad import tensor as f, probably. And it'll work. I guess that's kind of clever. Too much rely on vibe coding. You don't learn things that way. I don't want to do everything that way, though, Liberty. Like, I actually, like, the long chains of ops that way as your only model of doing stuff is not great. So, yeah, I think what we're going to do, right? And actually, this is going to end up looking exactly like torch functional, which is fine. So they're using, if I'm not wrong, I thought of this before. I don't think I ever had a reason to implement this in anything with Puffer, but I'll show you something kind of cool. So you can call functions of a class in Python, and you can pass self explicitly. Does that make sense? So if you have if tensor has a method that is soft plus, you can call capital T tensor dot soft plus and pass it a tensor as that self arg. So you basically, the way Python is written, you kind of get a procedural API for free, or functional API, whatever. More procedural API, I guess. Yeah, procedural API. So actually, this thing here, I can actually delete these, and I think I can just do f.where, and I think that this works. And now it shouldn't be f, right? Like, I'd actually think it would be pretty cool if these were just in the Tinygrad space, so you could just do like tiny.where. Okay, though. So now, we're not ready to do this yet, but I'm way happier with this now, because this is going to be virtually identical, is my hope. I think this is going to be virtually identical. To get rid of this, so this is now, what do they call? They say tensor.timing uniform. Okay, cool. So there are no biases with this, but we'll just let that slide for now. So we'll just do self.toHidden and out is going to be tensor linear. And this is just dim inner times 2. You don't need a bias. Out. This out is going to be obnoxious, and we're not going to use it anyways for this. So in the interest of time, since I have limited time today, I'm not going to do this. And then, let's see, do they have RMS norm? They do. Oh. They even have linear. Oh, they actually do have linear. So we should just use this. Yeah. This actually is going to be way easier than expected. So this is, I guess, what they mean by their torch compatible API. Give it a torch. The GPU thing. Yeah, they should have the docs linked easier than that. Available. Oh, look, they literally, yeah, so it's just like this. And then where's the device? Wait, where does this go onto GPU? Is this not on GPU? Or is it on GPU by default? Figure that out in a bit. Zeros? What about stuff like zeros? It's gonna be under tensor, right? So it's probably gonna be like under F. Put output hidden. Cool. What are you supposed to do about this? Ah, there it is. nn.state.get parameters. Easy, they already thought of it. LLVM context beam equals 2. So wait, it wasn't executing on CPU before, was it? Okay, so I don't think they have a sequential. Oh wait, they do. F.sequential. J is not exactly typical, pretty easy. So far, I'm so it's gonna take me longer than just a couple hours, obviously, of playing with it. I thought I was gonna have more time today. I didn't know that I was gonna have, Thanksgiving was at 2. I don't know. But, at least this gives me Like, so far, I've been pleasantly surprised, and there hasn't really been anything that's clearly, oh, this is just bad. Which, that's a lot coming from me. Gelu. Well, I mean, I don't know, Convert. There's some stuff I've heard with Tiny. Like, if I just look at... Let's see if it's gotten better. Oh, this is exactly what I want a library to look like, actually. Except that. Yeah, so things like this are like... I don't know why you write code like this, right? I guess... does Python force you? No, it really doesn't. It's kind of a little golfy for my liking. You know? Me neither, Tim. Reduce must support 2 iteration. Okay, so I actually don't know then. They have a proper sequential in this. Golfy means that they kind of lost track of the goal of, like, keep it as simple as possible, and they start, like, putting a lot of shit on one line just to make it shorter when it doesn't actually make it easier to read. That's basically the only... That was the one thing kind of putting me off, you know, from the source. But then, like, the thing is, slightly golfy code beats the hell out of the monstrosity of the Torch code base. Like, the Torch code base is just fucking bad. Like, there's no excuse for it. It's just, like, the worst excesses of big tech writing 10 times the amount of code they need for absolutely everything. You literally can't even find operations in that code base half the time. I mean, they named this thing sequential. So, I mean, presumably you can use it like this. Ah. Okay, they don't exactly have the same type as sequential. But that's fine. You know, I really don't need it. Not having module list on the other hand... Oh. Well, wait, you don't need it, lol. It's literally... Yeah, you don't need module list, duh. That's a Torch thing because Torch is dumb. I forgot about that. Okay. I'm happy. Not callable because it does not have forward function. Forward. Yeah. Oh, we need state. State. Does anybody know, is this thing on GPU by default in Tinygrad? Like, I didn't see device stuff anywhere. I think if I end up using this, this would have to be really good for me to, like, swap PyTorch completely. I think if that happens, I have to just order another server from the guy out of principle. I technically have the funds bookmarked for it anyways at some point. He actually, it was kind of funny. So when I was having trouble with my boxes, like, he sent me, like, a bunch of pictures of him taking apart the tiny box just, like, in 10 minutes. Like, you fucking imbecile. Like, how the fuck can you not take this box apart after several hours? And I had to tell him, like, dude, the front panel on mine didn't come off like the front panel came off on yours. It took 100 pounds of force, and then it freaking warped the metal. I'm not doing it wrong. This case was just fucked. uh, and there were a few other things as well. It's like, alright, guy thinks I'm eating glue or something. We did the warranty. They don't really have much of a warranty in the first place, dude. Hey, Spencer, it's surprisingly so far so good. Like, surprisingly, pretty damn good so far. Happy Thanksgiving as well. What happens if I put this breakpoint inside? Does it work or does it break because of the jet? If this works, I will be impressed that they thought of this. Nice one. So, I mean, this definitely kicks the shit out of Jax. Now, whether this is the end-all be-all is, we shall see. I've just been testing Tinygrad out, man. With like small models and seeing how good it is. Pretty much what I've been up to. Train step. State. State. What did you breakpoint and saw it hit a state line? Oh, that? I was just happy that the fact that it doesn't break your debugging when you have JIT on. So I put a breakpoint inside of something that has a JIT decorator on and it didn't break. Like basically everything torch breaks if you do that. I think Jax breaks if you do that. Jax and TPUs. No, Jax is dog shit. I just, I, I honestly just hate everything about that, like, framework. Jax is just like, it's like such a Google thing as well. It's like oh, we are so clever. Look, we came up with this whole new way to write code, and like, woe and behold us. And it's just garbage every fucking time. Like there aren't enough real problems to solve at Google or something, so they come up with problems so that they have problems to solve. I don't know. I mean, like, all you have to do, like, I had to be, like, to their credit, I had the, I think the Flax dev, yeah, the Flax dev messaged me, like, hey, I saw your post, what can we do better? And it's like, I try to be nice, right? Because it's like, okay, you're trying to build stuff. I can always appreciate that. But, like, look, when I look at an RL code base by somebody who I know is actually good, and they're writing 7 nested functions, and your framework is basically pushing people to write 7 nested functions, and every repo is like this, even by people who I know write good code, your framework sucks. Bad arg. I can always appreciate people trying to, like, actually caring and, like, trying to build stuff. It's just like, at some point, there's just such a big gap. It's just very difficult, you know? Bad arg. See what stack does in Tinygrad. int args, star args, tensor. Oh. Man, why do you do it this way? There are like a couple of these like really annoying discrepancies. Hang on. I don't know. I think the whole functional thing is like an overreaction to object-oriented programming being shit. And then it's like they just went and made something somehow even worse. Just like not if you just like delete inheritance and delete okay, there's actually, to be fair, there's a lot of stuff you need to delete. Just go write some C, you'll figure it out. Int object. I will say that their error messages here are quite confusing. Yeah, their error messages could be better. Oh, you know why? That's super annoying, man. They made it a mandatory keyword arg. Okay, this is actually a pet peeve now. They're kind of using some of the lesser known features of Python because like this is a mandatory, so this is like now a mandatory keyword arg. So if you actually pass it without the keyword, you're gonna get the wrong result. I almost can't fault him for it. It's like should just freaking pass it as a tuple though, honestly. I do this as well. Hmm. I don't know. I'm usually in favor of just like not using every single damn fancy feature in the language. Like star args, okay. Like star args with keyword arg is eh. The one that's really bad is you can just put a star like before keyword args without having star args, and then it'll also be mandatory keyword args. There are like a bunch of weird things you can do in Python technically that like doesn't mean you should necessarily. I'm gonna take beam off. Cool. This runs. Now we're gonna actually, I think for the real perf comparisons, it's gonna be a bit more work. But this was a good start. So, things I've learned so far. It seems like there is some hope of this actually being reasonably fast. It's basically identical to Torch. So, this is something that I almost wouldn't feel too bad providing for users if it's like almost identical. And I have really good reason for it. And apparently they can do kernel gen and stuff. So we might be able to do some stuff with that as well. I think it's going to take a lot more investigation, but this is so far, the first couple hours I've spent with this is enough that it's worth spending another couple hours. And then we will see from there. All right, so this is, yeah, we will have to see from there. I've got to go get ready for Thanksgiving. So for folks who've tuned in, happy Thanksgiving. I might stream this later. I might take the evening off. I think people are going to probably be doing Thanksgiving things anyways, for the most part. So I'll probably just pick this up either tomorrow or maybe Saturday. You know, depends on what I'm feeling like. We'll see. But if you're interested in my stuff generally, everything I do here is all free. It's all open source at puffer.ai. The only way this project makes money is through contracts with larger companies that want to get the best out of our tools, that want custom sims, stuff like that. Everyone else, all our stuff is right here. Free open source. Start the repo. Helps feed the puffer. Join the Discord if you want to get involved with dev. And you can follow me on X for more reinforcement learning content. I post educational stuff once in a while. We've got a nice collection of articles, different topics. And yeah, that's going to be about it. So thank you. See you around.